Module 6, Lesson 6, we're going to start looking at using mean as a way to describe the center of distribution of data. So what I want you to do is go ahead and jump on down to the exercises. So this is just an example of a dot plot that was shared earlier in Module 6. We covered it right before I-STEP. And just as a reminder, every dot represents how many of that number there are. So that's 1, 5, 1, 6. That would be 7, 7, 7. And then you have all of those 8s, all of those 9s, and that would have to be put in a list for you to then actually be able to accurately calculate the mean. So when we go down here to the first example, it says, Michelle asked 10 of her classmates for the number of hours they usually sleep when they're in school the next day. So this is an example of the response. They had 8, 10, 8, 8, 11, 11, 9, 8, 10, 7. And they said, how do you think Robert would organize this data? What do you think Robert would say is the center of these 10 data points and why? And so because he used a dot plot, it would mean that he would most likely do a dot plot again. And so a dot plot would just be a line. We'd put all the numbers on there, and it looks like we go from 7, 8, 9, 10, and 11. And then we just have to see how many there are. So there's 1, 7, so that would be 1 dot. And we have an 8, that's 1, 2, 3, 4 8s. So that's 1, 2, 3, 4. There's 1 9. You have 2 10s. And then you have 2 11s. So looking at that, it doesn't really create a very nice bell curve. So this one, you could see it here visually and you could say, oh, well, the middle is about right here. Well, this one is a little bit different. It's a little bit skewed. And so you'd probably say the middle was between 8 and 9, since 8 is the highest one. And the question that they ask on the next page is, do you feel that this is a good way to measure the center of the data? And I would say no, because it doesn't have the bell curve. So the dots don't create a bell curve, and a bell curve is just like, you could almost draw, and those are parentheses, but you could draw a line like that, and so the middle would actually be a visible middle. I mean, like, it would be where that line, or where the curve goes up, the middle would be there. Where for the example that we have, it actually was more like this, and that's not very obvious. And so we can't really use that because it doesn't provide us a clear understanding. And so this is where mean comes in. So maybe your data isn't a perfect bell curve, but you have all these numbers and you want to figure out what's the middle. You can use mean or average to do that. So down here it says, the measure of center that Michelle is proposing is called the mean. She finds the total number of hours for the sleep. That is 90 hours. She has 90 cubes, and she gives them out to 10 different people, and the average ends up being 9. Now, you don't have the cubes, but say you have 10 stacks of cubes representing the number of hours of sleep for each of the 10 students. Using her method, how many cubes are in each of the 10 stacks when they are done sharing? So she had 90 cubes, so right here, because that was the total number of hours. And so that would have been all the numbers added up from the previous page. So that would have been a 7 plus 8 90 total hours. So we added all the numbers from the previous page together. And then what she took was, she had 90 cubes for the 90 hours and divided it by 10 students. And you'd get 9 hours per student. Now, this is just an average. This isn't the actual true statement because the numbers were all different. So noting that each cube represents 1 hour of sleep, and interpret your answer in the number of hours, what does this number of cubes of stack represent? So it's how many hours on average. Actually, you could say it represents the number of hours on average that each student slept. And then it says, suppose that the student who told Michelle he slept 7 hours changed his value to 8. What does Michelle's procedure now produce for her center of the new data? What do you have to do with that extra cube to make her procedure work? So what you actually have to do is you're going to take 1 divided by 10, because he said he slept 7, but it actually was 8. And from here to here, that's going to be plus 1. And so if our total was now is 91 hours, we'd have to take 91 divided by 10, and you get 9 1/10 hours per student. So down here at the bottom, what we're doing is you're going to find the total numbers. This is the formula related to mean. So you're going to find the total, and then you're going to divide by the number of numbers. And that's all you're doing. So let's go to the next page. So suppose that Robert asked 5 6th grade graders how many pets each of them had. Their responses were 2, 6, 4, and 1. Robert showed the data with cubes as followed. So we have the 1, 2 2s, 1 4, and 1 6. Note that one student has 1 pet, 2 students have 2, 1 student has 4, and 1 student has 6. Robert represents the data in a dot plot. So you go down to the next example. You have the dot plot. And then it says he wants to illustrate Michelle's fair share method by using dot plots. He drew the following dot plot and said that it represents the result of the student with 6 pets sharing one of her pets with the student who has 1 pet. So I'll say that again. He drew the following dot plot and said that it represents the result of the student with 6 pets. So took the one student who had all of these extra ones, the 1 6 student, and then shared one pet with the student who has 1 pet. So over here it says Robert also represented the dot plot above with cubes. His representation is shown below. So now it's 2, 2, 2, 4, and 5. Robert does a fair share step by having the student with 5 pets share one of her pets with one of the students with 2 pets. Draw the cube representation that shows the result of the fair share step. Draw the dot plot that shows the result of this fair share step. Robert does another fair share step by having one of the students who has 4 pets share 1 pet with one of the students who has 2 pets. Draw the cube representation of that. We are not going to use this page. So go ahead and turn to the next page. And you're going to not do this page. We're going to jump over to number 4. So number 4, suppose that the mean number of chocolate chips in 30 cookies is 14 chocolate chips. Interpret the mean number in terms of fair share. Describe the dot plot representation of the fair share mean of 14. You don't need to worry about that part. What I want you to do is right here. And all I want you to do is find the mean of these numbers. So you're going to first add the numbers to find the total. Second, you're going to divide by the number of numbers. And that will be the end. We'll move into lesson 7 on Wednesday, but what I will be checking when I return will be, have you done this question and answered it correctly?